All right, good morning, ladies and gentlemen. What we're going to do is go ahead and walk you through a radiated energy calculation. So here's my problem. Large animal is placed into a new habitat. The animal's temperature, it says, is 98.6 degrees Fahrenheit. So I'm going to go ahead and write that here. And the habitat's temperature, it tells me, is 56 degrees Fahrenheit. And it tells me determine the net energy transfer. So I know that that's Q. And these are just temperature, we'll call it temperature 2 and temperature 1. The big one will be 2. The small one will be 1. And it says that we're going to leave that animal there for 11 minutes. 11 minutes. So I know that that's going to be a lowercase t, and I'm going to have to convert it into seconds. The animal's skin emissivity, it tells me, is 0.4. 0.4, no units with that. And the surface area, it says of the dolphin, it should say of the animal, is 0.59 meters squared. Round to 3 decimal places. What are my known values? I know E is 0.4. I know A is 0.59 meters squared. I know temperature 2 is 98.6 degrees Fahrenheit, and temperature 1 is 56 degrees Fahrenheit. And I know the time is 11 minutes, and I'll go ahead and convert that. 11 times 60 is 660 seconds. Just multiplied by 60 to get that. All right. Anything I'm missing there? It looks like I got it all. What do I not know? Well, they asked me to solve for Q, and I've got everything for P net, which is P net is Stefan's constant, and that's given to me right here. So I can add that as a known value. 5.6696 times 10 to the negative 8th power watts per meter squared Kelvin to the 4th. Area, emissivity, T2 to the 4th minus T1 to the 4th. One thing that's a little bit tricky here is because Stefan's constant is in Kelvin to the 4th power, that means I need to convert my temperatures into Kelvin. And Fahrenheit to Kelvin means I'm going to do Fahrenheit, the temperature in Fahrenheit, minus 32 divided by 1.8 plus 273. So 56 minus 32 divided by 1.8 plus 273 gives me 286.3 repeating Kelvin. And that again is my T1. And my T2 is going to be 98.6 minus 32 divided by 1.8 and add 273. And that's 310 Kelvin. So the first thing I'm going to do is the Kelvin. So 310 Kelvin minus 286.3 repeating Kelvin, and to the 4th power. So I got to do that to the 4th and that to the 4th. So I'm going to do them to the 4th first. So I'll go ahead and put the little caret 4. So 310 becomes 9, 2, 3, 5, 2, 1, and 4 zeros minus 286 point, and I'm going to put a bunch of 3s to the 4th, which is 6, 7, 2, 1, 8, 3, 1, 7, 3, 0. And now I'll subtract them. So 9, 2, 3, 5, 2, 1, 0, 0, 0 minus the answer, which gives me 2, 5, 1, 3, 3, 7, 8, 2, 7, 0. And I'm going to plug that into Stefan's constant. 5.6696 times 10 to the negative 8th power times the area, 0.59 meters squared. That's watts per meter squared Kelvin to the 4th.